Greetings, M Squared here. We're going to talk about coordinate proofs. This is our second learning target in this chapter. This one deals with generalized points and not specific coordinates. So we still have to know the same three formulas that we did in learning target 1. So just to recap, slope formula is used to prove things parallel or perpendicular, because if the slopes are the same, we have parallel lines. If the slopes are negative or opposite reciprocals, we have perpendicular lines. To prove things congruent, we're going to use the distance formula. To prove things bisect each other, or that something's a midpoint, we're going to use our midpoint formula. So with that in mind, we want to use our x and y axis when we're placing these points, when we're actually drawing pictures to our advantage, putting things on the x-axis so that we have a 0 y coordinate. When things are parallel, making sure that our coordinates of our y's are the same because they're the same distance up, things like that. So we're going to do our first proof. We're going to prove that the mid-segment, it says prove that EF is the mid-segment of the trapezoid. So we have to prove that this guy intersects, is parallel to the bases. So for that, we're going to have to find the slopes. So we can find the slope of this. The slope of BC is B minus B over C minus A. Well, B minus B is 0, so the slope of that one's 0. Then the slope of this one, 0 minus 0 over 0 minus D, is still 0, so we know that these are parallel. They'd have to be if it's a trapezoid. And we have to prove that this is the mid-segment and that it's parallel to those as well. Well, in order to prove it's the mid-segment, we have to find the actual midpoints. So we use our midpoint formula for that. So we're going to find the midpoint of AB. And to do that, we're going to take our x-coordinates and divide it by 2, and our y-coordinates and divide it by 2. So our x-coordinates are A and 0, and A plus 0 is A, and B and 0, so that's that guy. Now we're going to find the midpoint of CD, and then that will be the coordinate of F. So B plus, I need to start with x coordinate, C plus D over 2, and B plus 0 over 2. So here's my E, and here's my F point, and now I need to find the slope of that to show that it's actually the mid-segment. So I'm going to find the slope. So I'm going to have B over 2 minus B over 2 over A over 2 minus C plus D over 2. Well, half of B minus half of B is just 0. Then it doesn't really matter what the denominator is. So the slope is 0. So I've just shown that all the slopes of those three things are parallel. Therefore, the mid-segment, it's the mid-segment, because the mid-segment is parallel to the bases of a trapezoid. So I would say EF is parallel to BC and AD. Therefore, my little triangle with dots means therefore it is the mid-segment. And I'm abbreviating. Okay, a couple more. So on this one, we're supposed to prove that the quadrilateral ABC with midpoints E, F, G, and H, which they didn't give us, so we're going to have to find it. We're supposed to write a proof about E, F, G, H being a parallelogram. Again, if I'm proving something parallel, I need the slopes. So first, I got to find the midpoints. So notice that the points they picked are all even, and that's nice because when we go to find our midpoint, we're going to just divide, and it's going to be nice and pretty. Because when we divide by 2, the 2's are going to cancel. So this midpoint, I'm going to say 2b plus a negative 2a. That's going to be divided by 2. It's going to be b minus a, and then that's going to be a c. And I don't need, when I divide by 2, the 2's cancel out, so I really didn't need that line there. So point E is b minus a over, comma c. And I'm going to find point F. So point F, I'm going to find the midpoints of B and C. So 2B plus 2A divided by 2 is just A plus B. And 2C plus 0 divided by 2 is C. And now for G, I've got to find the midpoint. So I'm going to add the x's and divide by 2. So that's A plus D, and add 0 and the 2E, and I get E. And finally H, and that's D minus A and E. So now I have to prove it's a parallelogram. And so you can see that the y's of these two are the same and the y's of those two are the same. So what's going to happen when I find the slope of EF? well, C minus C, so I have to find the slope of all of these things now to show that it's a parallelogram. So I'm going to have to find the slope of EF and the slope of GH. I'm fairly certain already that those are parallel because they have the same y values. So that's just going to be C minus C is 0, so it doesn't matter what the denominator is. The same thing there. But I also have to find the slope of FG and HE. And so to do the HE, I would say C minus A, C minus E over B minus A minus D minus negative A. So the A's would cancel out, and I just get B minus D. And then I'm going to find the slope of FG, so C minus E over A plus B minus A minus D, so that's just going to be A minus D, I believe. No, I used the wrong one, didn't I? No, FG, was I finding FG? Yes. I don't know what happened there. FG. So anyway, they're supposed to be the same. These are parallel. I must have goofed up somewhere. This is the same. So let me just go back to HE. B minus A. B minus A minus D plus A, because I subtracted negative, I get B minus D. And then FG would have been A plus B minus A minus D. Anyway, they're supposed to be the same. I can't find my mistakes, so we're going to move on. But anyway, they're the same. You would say opposite. Sometimes I can't find my mistakes quick enough to show the video. Opposite sides are parallel. Therefore, because the slopes are the same, therefore EFGH is a parallelogram. So if it wasn't a video, I would have time to find my mistake. But this is already the third time I've started this video, and so we're just going to live with the mistake. Here we're going to prove the diagonals of Aramis are perpendicular. So I've already gone ahead and drawn the Aramis. I just want you to know that I used 0, 0 as one of my points. And then I went up a certain amount and over a certain amount. And I'm going to call that up B and that over A. And I have to just switch it around for this side. I have to go over B and up A. And then I had to do the same thing. I had to go up the same amount and then over the same amount. So I'm calling this point, I went up from the original A, I went over B, and from the original B, I went up A. So you'll see that. That's how I got those points, is by calculating how much I go over. Why do I have to do that? Because it has to be a rhombus. They have to be equal. If I don't do that, it won't be equal. So now it's asking about the diagonals. Well, that is AC. So I'm going to find, it says that they're perpendicular. So I'm going to find the slope of AC. So the slope is y minus y. So here's my y minus 0. So over x minus 0. So there we go. Y minus y over x minus x. So my slope, sorry, that's a slope, not a distance. The slope is a plus b over a plus b. And can anyone tell me what that is? It is 1. We can simplify it. If you use different letters, you might not get 1. You might get something else. Okay, so let's find the slope of the other diagonal, which is BD. But you should still get negative reciprocals at the end, as long as you make sure that the letters are coordinating. If you just randomly pick any letters, it doesn't work. So you have to really be careful how you place the letters. So let's find the slope of BD. So B minus A is y minus y, and then A minus B. And I don't know if you remember this, but these are actually opposites. If you're not sure, you can always just pick two numbers. What's 5 minus 2 over 2 minus 5? Well, 5 minus 2 is 3. 2 minus 5 is negative 3, so that's a negative 1. So anytime you have two numbers that are the same, that are the difference, but you just switch the order, but you're still taking the difference or subtracting, that's always going to get a negative 1. So these are indeed opposite reciprocals. And then I would say diagonals, I would say up here, I would have said it. I'm not going to write it all down. The slope of AC and BC are negative reciprocals, therefore the diagonals of the parallelogram are perpendicular. But say that other stuff first. The writing is super important in all this. Okay, and lastly, prove that the diagonals of an isosceles trapezoid are congruent. Okay, so I already drew an isosceles trapezoid. I put the center on the y-axis so that I could go over the same amount, and that helps a little bit with my letters. So I'm going to go over A both ways, up B both ways, and then over C both ways. That means it's an isosceles trapezoid, because I figured that out. Now we have to show that the diagonals are congruent. That is the distance formula. So let's talk about the distance formula of these guys. That's one diagonal. So the distance formula says x minus x. So if I start here, it's a minus a negative c. That's going to be a plus c squared. And then b minus 0. That's a b squared. And then I add those two together. So that's the diagonal of 1. Now I have to find the diagonal of this one. So I'm going to say b minus 0. That's b squared. And then negative a minus c. So plus negative a minus c squared. So it looks like maybe they're not congruent, but remember, if we actually had numbers like negative 3 minus 4 and we squared it, that'd be negative 7 squared, and that would be 49. And so 3 plus 7 and a negative 3, 3 plus 4 and a negative 3 minus 4. When I square it, I'm going to get the same number. So those are actually congruent. So I would say, I would then write, I'm not going to write it here, but I would say the diagonals, using the distance formula, I found that the diagonals were congruent. And that's what you would do for that one. Okay, sorry about that mistake there, but I'll figure it out after I say goodbye. M squared, signing out.